Today we finish off Project Lime Dime with a shakedown at the track and convert a powerful Mustang to waterless coolant.
Welcome to Engine Power. I'm sure you recognize this project from last season. Well, the weather got cold and all the tracks closed, so we set it to the side. We named the project Lime Dime. Clever, huh? Well, despite its color, it had a good body and a good chassis, and the price was right, so we bought it. Don't let all this smoke fool you. It only packs a stock 4.3-liter Vortec, really good front brakes, and bald tires to let it happen. But it's a good mild street truck. So our goal was to create an 11-second street strip toy powered by a nicely modified 427 big block Chevy. And to speed things up, we accepted a little help.
We let Ryan from Truck Tech have a go on it with us.
Oh, it's already got dual exhaust. Shoot, you guys are off to a great start.
A roll cage was his plan, but not till we strip it down.
You guys are keeping the stock axle, right?
No, it's gone. Fuel tank's gone, charcoal canister, exhaust, drive shaft, everything. Including the engine, still warm from the burnout. GM introduced these in 1985, along with the phrase Vortec technology, because a new head design created a Vortec inside the combustion chamber for improved air and fuel atomization. Now, modern Vortec engines are named for their approximate displacement in cubic liters.
You think a big block's going to fit?
I think it's going to fit it nicely with some minor work.
The AC box, new booster, master cylinder.
Yeah, no, there's
Get rid of the ABS.
Plenty of room in here.
Ryan wasted no time getting started. He's one of those guys that sees it in his head from start to finish, like creating safe and street-friendly door bars. He also got us lightweight Aerospace brakes from Summit with 4-piston calipers for the front and rear.
Everything looks good on this.
On the other side of the tech center, Pat and I started with a complete 427 GM crate engine that we found at a local swap meet for $3,500. Now, it looked to be in great shape and the money was right, so we took a chance.
Let's see what our money bought us here.
We ran it just like GM did with a 770 CFM carb, HEI distributor, premium fuel, and 36 degrees of total timing. The RPM sweep was from 3 to 6,000, and it cranked out 469 horsepower at 5,500 RPM and 483 pound-feet at 4,000.
Our goal was to extract every bit of power we could with minimal parts change and some do-it-yourself racing tricks that make a difference. We handled the cylinder heads by flowing them on our Superflow bench, then tuned up a single intake runner and combustion chamber so the guys at the School of Automotive Machinists could match the other 7 and give them a nice valve job. To free up more power, we showed you the difference in ring tension and what it would be worth by freeing up friction. Making parts shiny is not just for looks. We polished the pistons and combustion chambers to isolate heat in the chamber for a more efficient burn.
Then the crank was reunited with the block and the main caps were torqued. Low-tension rings were placed on the pistons and they filled up the bores. A hydraulic roller camshaft was installed, followed by a billet timing set, and then put back on the dyno. After several timing changes and some carb tweaking, it cranked out 509 horsepower, 502 pound-feet of torque. Nice. That's a gain of 40 horsepower and 19 pound-feet. Then we dropped on an NOS cheater kit nitrous system, and 150 shot yielded 669 horsepower, 784 on the torque gauge.
Lime Dime is ready for assembly and we have our hands full. First, a Curry F9 fabricated rear end was assembled and installed using Caltrac monoleaf springs and traction bars. Then it was time to get the engine mounted using front plates, followed by the TH400 transmission. After that, we grabbed a little help and got the bed mounted and our down bars reinstalled. Weight over the axle is important for traction, so we mounted a pump gas and race gas fuel cell, battery box, and the radiator in the bed. The necessarily complicated exhaust was next. It started with massive up and forward turbo headers. 3-inch pipe made its way under the truck, where it has mufflers and electric cutouts.
Everything was easy from here, like all the plumbing for the fuel and cooling systems, and the front suspension was upgraded with tubular A-arms and Calvert Racing front shocks. The wiring was all wrapped up after hours, and an aluminum drive shaft made the link from the trans to the differential. Then the distributor was dropped in for this. Got fuel?
All right, let her rip.
Ignition, you ready?
Yep. Good.
Woo!
It lives.
That was a lot of work. That was a lot of work.
Oh my goodness.
Even at that point, the work wasn't done. We still have some setup work to do to the suspension, dial in our electronics, and do a little parking lot shakedown to make sure the truck's ready for the track. Plus, we still have to load the rig with all the necessities for this trip. All that right after this break. To get the truck ready for the parking lot, we're going to go ahead and start by setting all the tire pressures. Then we're going to go underneath and adjust the Caltrax bars for the initial setting. Then we'll make sure the timing is where we want it for the naturally aspirated runs. We'll go ahead and weigh the truck just so we know, and then fill the nitrous bottles. We're going to run 12 pounds of pressure in the rear ET streets as a starting point. Now, the more pressure you run, the faster the vehicle will go, but there is a point when too much pressure will induce wheel spin at the launch. Up front, we're running 32 pounds. Much more than this will cause minimal tread contact on the racing surface, which is fine for speed, but will get you in serious trouble when you apply the brakes down at the deep end. Now, setting up the Caltrax requires a driver to be in the pilot seat. This is to get an accurate preload setting on the bar. It's simple to adjust. Turn the force transfer link until the spring stop bolt contacts the spring, then add a quarter turn. Locking the jam nut finishes the setup. Repeat it on the other side. Now onto the shock adjustment. Since we're running a transmission with a trans brake, the recommended setting from Calvert Racing on the rear shocks is between 1 and 3. Up front, they're non-adjustable 90-10s designed for maximum weight transfer. Here we go, Pat.
Light her up. Next, we can check the timing to make sure it's where we want. Total for naturally aspirated runs will be 36 degrees. Next up, we're going to find out what the Lime Dime weighs so we can get a guesstimate on how fast it's going to run, and we're going to base that off of my trusty dusty Moroso power speed calculator. Our scales are Intercomp's QuickWeigh SW650 scale system. It's a wireless setup and super easy to use with tons of options. With the appropriate scale under each tire, we'll lower the truck onto them. Looking at the digital screen, we can see total weight, front to rear bias, as well as corner weights. The power speed calculator is simple. Line up the weight of the vehicle with the known horsepower rating and look at the results. Our truck should run in the high 10-second range at around 120 miles per hour.
Before it sees those speeds, we're making sure everything functions properly at a low RPM, starting with the line lock. By pumping the brake pedal 3 to 4 times and holding it firm, press the button on the shifter. This activates a solenoid and keeps the pressure on the front brakes. When you take your foot off the pedal, it relieves pressure to the rear so you can do a burnout. When the button is released, it lets the vehicle roll out. Now the trans brake and 2-step rev limiter, which are tied into the same button on the steering wheel, will get a test. When it's engaged, you mash the go pedal to the floor. The brake locks the forward and reverse gear at the same time so the truck won't roll through the beans. At the same time, the ignition is put in the low RPM loop, which is the set RPM you launch at. Listen to it again. Enough of the parking lot, it's time for the track. We're here at Beach Bend Raceway in Bowling Green, Kentucky, and it's actually home to Holley Performance and their biggest event, the LS Fest. Now the track is freshly scraped, so it's not ready for the season, and neither are we. We've still got a couple things to finish. A lot of heat comes off of these headers, and we don't want to cook the fiberglass hood. DEI's underhood thermal acoustic lining will protect it. With the shape we need marked out, we can cut it. Then remove the backing to reveal the self-adhesive stickiness. And apply it. In the bed, we're adding 93 octane pump gas to the big cell. The little one is for race gas we're not sure if we can use today.
Either way, we're still going to sling some rubber, so here's a quick tip. Spraying WD-40 behind the rear tires won't let rubber stick to it. It's easy to clean and it won't hurt the paint. This S10 transformation has been a long time in the making. And today, it's ready for its high RPM shakedown. Coming up.
Now we're down on the racing surface, and here's what I mean when I mentioned the track was green. They usually scrape the rubber off of the racing surface from about the burnout box to the 60-foot mark. That's because over the winter, the rubber will actually absorb moisture, and if they were to run on it again, it would chunk up and ruin the racing surface for that weekend. Now what that means is this track is super slick. So we're not trying to run the quarter mile or be heroes. We're here to shake the truck down and make sure it's ready for when we take it to an event. We'll be the only ones running this track today. So to ensure safety, we're walking the entire surface to make sure it's free of debris, water, or any other foreign matter that would make it unsafe. I think you're right. Out past the 60, cut a half a tire width over to the right side.
Yeah, it's not horrible. It's actually really well covered, really well stuck down. So
we'll lay some on top of it and see what we can do.
That's what you're supposed to do.
Yep.
Before we start, we're taking advantage of the latest spark technology entering the high-performance market. E3 now offers racing spark plugs. Chief designer Don Ward tells us why.
E3 has a complete line for racing. We will have motorcycle plugs up to top fuel. As a matter of fact, last year we were testing our new top fuel plug and we won 5 races last year.
E3 started making plugs for small engines back in 2004 and quickly expanded into the automotive market with great success. And with their continued R&D, they're carving their own niche in the racing industry.
Diamond fire ground wire technology. You have a diamond in the center. You have more sharp edges to fire to. Takes less required voltage, and when it burns more fuel, it makes more power.
I don't care if it's shakedown, 60 foots, or just burnouts. I'm getting safety gear on. All our safety gear came from Summit Racing. Now this is an area your life depends on, so don't spare any expense. With water in the box, the maiden voyage starts. Using the line lock, Pat's going to do a 3-gear burnout. Release the button and get some rubber laid down. Flawless. Man, that looked good and sounded good. How'd it feel?
It sounded fine. The track is like a piece of ice right now, so we're gonna put a little bit more down.
And we did, with a little to the left and another to mix it up. Well, we know one thing. There's enough rubber down in the groove for us to continue. Next up, the first trans brake launch at the track. The launch RPM is soft right now at 3,000. Not bad at all. Good tire wrinkle and a little sunlight under the front tires. I see potential.
We're too low in the RPM range for the engine.
That's why the truck fell on its face there.
Yep.
All right, we chose to make an adjustment right now. We're gonna raise the limiter on the 2-step. That's done on the MSD box, which we have under the dash, and it's hard for you to see.
Burnouts raise tire temperature, and temperature expands air. So we need to purge it back down to 12 PSI. Another burnout gets the tires sticky. And the same process with a little higher launch RPM. That time, a 177 60-foot, which is nothing to write home about.
Light on that one was a 006.
Oh, that's better.
That was very nice.
The old man hadn't lost his touch.
Old man still's got the touch on the button, absolutely.
It feels good, the brakes feel good, the engine feels good. I opened up the exhaust on that last one.
I heard that. Now I get to have a little fun in the Lime Dime. Doing burnouts in this thing are a blast, and Pat was right. Everything feels good and tight, which also makes us feel safe. Safe enough to run race gas and nitrous, but not today. We'll show you how to dial that in at this track's next test and tune event. Can't wait.
Up next, a conversion to a waterless coolant, the end of overheating.
Believe it or not, the cooling system on a high-performance application is just as important as its oiling system. Whether you have iron or aluminum parts, both are susceptible to electrolysis and corrosion, and that can wreak havoc on your engine's cooling capacity. And what causes that problem is water present in the system.
New technology is always helping us gearheads go faster and our parts live longer. Well, today it's with a waterless coolant that has several benefits over the water-based types you've been using. Now, it's called Evans High Performance Waterless Engine Coolant, and today we're going to show you how and why you should switch to it.
Working its way.
Mike Torville and Mark Stone from Evans Cooling Systems know the ins and outs of their product.
Water-based coolants have been used for over 100 years. They typically comprise of 50% glycol and 50% water. Evans is unique in that we're the only engine coolant in the world that has zero water in it. So it has unique properties that are desirable for racing applications.
You're not going to boil Evans coolant in an engine, which means you don't form vapor, you don't have a vapor barrier between the liquid and the metal. Now, that means you always maintain liquid to metal contact, providing good heat transfer, keeping metal temperatures under control, especially at the higher temperatures where it matters the most.
The best way to illustrate the benefit of Evans coolant in terms of our high boiling point is this little science experiment we put together here. So over here we have a beaker of 50/50 antifreeze. You can see it's boiling away at 233 degrees Fahrenheit. And over here at 297 degrees, Evans coolant is completely stable. We still have another 75 degrees to go before the fluid would even boil.
That's why we brought in this 519 horsepower Livernois Motorsports engine, making it the perfect candidate for today's conversion. You must purge all the old water-based coolant from the system for the Evans coolant to work properly.
When it's empty, we can move on to the block drains. If you're not sure which pipe plugs are the drains on your engine, a quick Google search will help you out. When coolant stops draining, we can replace that plug. Introducing forced air into the system is next. A standard shop vac makes this a simple task. By blowing air into the radiator or expansion tank, coolant is being forced out of the heater core and the areas that retain the fluid. With all the old coolant out, we can seal the system back up.
Evans prep fluid is basically used as a flush to remove any leftover water-based coolant in the system. Now, you have to fill it to capacity because the engine will need to be started and brought up to temp to circulate the flush through the entire system. Now we'll fire the COBRA up and the prep fluid will do its job, working its way through all the nooks and crannies, removing as much water content as possible. When the temperature stabilizes, we can shut the car down and let it cool a bit. Now open the petcock and drain as much of the prep fluid from the radiator. End the block just like we did before.
The forced air procedure also needs to happen again, and you already know why. Now it's time for the final pour. It's the coolant that will last the life of the engine. No flushing or changing, and if it needs to be drained, save it and reuse it. Never add water or conventional coolant to Evans, it will reduce its effectiveness. Here's an easy reminder they supplied with the coolant.
The car needs to be started again and the system purged of any air. Leave the radiator cap off to let the air pockets move to the highest point, which is this tank. Once the engine is at temperature, we can shut it down and see if we pass the test.
By submerging a litmus test strip in for 15 seconds. Then let it sit for 2 minutes 20 seconds and compare it to the Evans pH scale. We should be between 0 and 3%. Anything over 5% means you have to redo the whole process.
Now that you've been schooled on Evans coolant, go ahead and make the change. Your car will thank you for it in the long run. You can pick yours up at summitracing.com. We'll see you next time.